So good morning everyone. So today I am going to explain the topic which is a network topology. In the previous classes we discussed about the different topics like which is voltage division principle, current division principle, and where we are going to apply the KCL, KVL, and how we are going to implement it in the different networks we seen. So now today we are going to see about the network topology. So what is meant by network topology? So the circuit, how we are going to lay out, how we are going to draw the different circuits, or how we are going to analyze the different circuits by redrawing those circuits. That is called as a network topology. So here, network, you already know that in network we are going to construct with the different elements like passive elements or active elements. So here the active elements like voltage sources, current sources, the passive elements like resistor, capacitor, all are combined together which will form a network. So in order to analyze those network, we are applying the different principles like Kirchhoff voltage law, current law, or voltage division principle, or current division principle, or whatever the nodal analysis, mesh analysis, whatever the concepts we are going to apply, that will be complicated. So that if the circuit is becoming very larger, that complexity of analyzing that particular networks by using these all concepts, that is very difficult. So in order to analyze the networks in a simple manner, we are going for the network topology. How we are going to simplify that analysis here? We are going to redraw that particular network which is having an active elements as well as the passive elements. We are redrawing that circuit like which is a branch, which are the passive elements with a single line, and nodes we are going to represent in a particular nodes. By taking that particular by taking that particular analysis or that particular circuit, converting that circuit, we are going to write the mathematical expressions. According to that one, we are going to analyze the networks. So that is called as a network topology. In basically network topology, we are going to use these three terms, which is a branch, node, as well as a loop. What is meant by a branch? So here we see the different elements like active element, which is a voltage source. So let us take this is a voltage source which is having a two-terminal device, and resistor. Resistor is also a two-terminal device. Capacitor is also a two-terminal device. Every two-terminal device is called as a branch. So every two-terminal device is called as a branch. So node. So in order to connect those branches, if this is, let us consider this is a branch, that is a resistor, and here this is another resistor. We join these two. We join these two ends of the resistor. So which will form a junction? This particular junction is called as a node. Okay. So branch is nothing but every element in the particular network is called as a branch. The joining of a branches which will form a junction. That junction is called as a node. So we are drawing the branches and with respect to the nodes. So which will form a closed path. So which will form a closed path. If there is any closed path, that we are going to consider as a node. That we'll consider as a loop. Okay. So branch is nothing but a two-terminal device. Node, by joining a two or more branches at particular point, that particular junction is called as a node. Loop, which is a closed path, which is a closed path of any device or closed path of any network is called as a loop. If in that loop there are different branches are there, no? So that branch are not repeating in the another loop. Whatever the elements we are going to use in a particular loop, those elements should not repeat in the another loop. If that is like that, then those two loops are called as independent loops, independent to each other. If there is no branch is repeated in the second loop, then those are called as an independent loop. These are the main terms we are going to use in a network topology. So next we'll go for. So how we are going to draw the different network, and how we are going to redraw the network. That redrawing of network is called as a graph. Okay, so redrawing of network by replacing the branches as well as the nodes, those are called as a graph. How we are going to draw the graph? You see here one example I shown here. So what is that example, which is a bridge circuit I taken? So this is a bridge circuit which is having the 6 elements or 6 branches are there. Each and every 2 terminal device is called as a branch, I already told. So here you observe this is a resistor A, which is this is a resistor A, so which is having a 2 terminal, and this is a resistor B, which is a 2 terminal device, and this is a which is a resistor D, that is also a 2 terminal device, and here the resistor C, which is also a 2 terminal device, and here these two ends are connected together, that is connected to the voltage source, which is called as a V, and that is also a 2 terminal device, so this is also called as a branch. And here this 3 and 4, here 1 2 3 4, 1 2 3 4, these are indicated with the nodes. So node, these two are connected with the galvanometer, that is also having a 2 terminal. So these 2 terminals, these are all the 2 terminal devices. How many are there? 1 2 3 4 5 and 6. So 6 2 terminal devices are there. So here that is called as a 6 branches. So here those are 6 branches here. So by replacing these 6 branches with a single line by placing a node. How we are going to placing a node? So any junction forms. So any branches connected together that will form a junctions, there that will exist a single node. So here you can take these two are joined there, no? So these two here voltage source and resistor C and resistor A. These 3 branches are joined together, which will form a junction. That junction we are going to indicate with the node 1. As well as here this resistor A and this galvanometer as well as resistor B. These 3 are joined together, that will form a node, that will indicating with the node 2. And here these 3 again C, D and G. These 3 elements are joined here. So these 3 will form a junction of 4. Okay. So and here B, D and as well as a voltage source, those are joined together, which will form a number 3. Okay, number 3. 1, 2, 3 and 4. These are the particular nodes. So while drawing, first you should put the nodes. So here I put the nodes like this, 1, 2, 3 and 4. So after placing the nodes here, join. Whatever the branches we joined, that node 1 and node 2, you place it. Here 1, 2 nodes are joined with a branch of A. So here this branch is replaced with a single line, that here I shown here, which is a 1 and 2 are joined with a single line with having a value of A. So having a value of A. Here I written A. Nothing but this will represent the branch A, nothing but a resistor A. Likewise, you draw for 2 and 3. So 2, 3 are joined by a resistor which is having a B value. So here I joined with a single line, 2, 3 with a value of B. And here 1, 4 are joined with the value of C. So here 1, 4 are joined with the value of C, and here 4, 3 are joined with the value of D, and here 4, 3 are joined with the value of D. So all resistors are replaced with a single line, just line segment, just joining of a nodes. After that, here galvanometer is connected in between 3 and 4, but there is no value of a galvanometer. Let us take that value is E. So here 2 and 4 joined together, which will take the value of E. And next here 1, 3 are joined with the voltage source. So 1, 3 are joined with the voltage source. Here also they did not mention the value there. So V is replaced with the value of branch F. So 1, 3 are having the value of F. So likewise you can draw the graph of any network. Just replacing the branches with a line segment which are joined to the nodes. So next, what are the terms we are going to use in a graph? So first one is a oriented or that is also called as a directed graph. And what is mean by a degree of a node? What is mean by a planar and non-planar graph? Here, first one, oriented or directed graph. So what is mean by directed graph? In the previous example we seen, right? So is there any direction with 1 to 2 or 2 to 3 or 3 to 4? Just we joined 1, 2 with the value of A. 2, 3 we joined with the value of B. Like that. But there is no direction. And how the flow of current or how the flow of that particular picture, there is no direction. So if there is no direction of any graph, that is called as a undirected graph. So undirected graph. So if we have a specific direction from one branch to the another branch, from one node to the another node, nothing but the path of movement of a network. If we indicate a path, then that is called as a oriented or directed graph. If we have any path of a particular network is called as a directed graph. What is meant by a degree of a node? So here I already shown one diagram which is here one node. This is a one node. One node is connected to how many branches? That A branch is connected here, as well as C branch is connected here, and F branch is connected here. So one node is connected to A, C as well as F. Nothing but three branches are connected to the particular node 1. So that will indicate the degree of a particular node. The degree of a particular node that can indicate how many branches are connected to that particular node. How many branches are connected to that particular node, that will indicate as a degree of a node. So can you tell me the degree of a node 2? Okay, so degree of a node 2. That node 2 is connected to the branch A, branch E as well as branch B. So B, A, E. So three branches are connected to the node 2. Then what is the degree of a node 2? Node 2 degree is 3. Okay, likewise third node is also connected to B, E as well as D. Three branches are connected. So the degree of a node 3 is, what is the degree of the node 3? That is also 3. What is the degree of a node 4? So node 4 is also connected to the three branches. So what is the three branches here? C, E as well as D. So these three branches are connected to the node 4. What is the degree of a particular node? That is also a 4. Okay. So that is the degree of a node. Next, what is a planar and non-planar graph? So if a graph does not consist any crossovers. So while drawing, the one branch and second branch should not interact, should not interconnect. So if there is no any interconnections or there is no any crossovers between the graph, then those are called as a planar graphs. If there is a crossovers, then that is a non-planar graph. Once again, the oriented graph is nothing but every branch or every node, the direction that should indicate. Then that is called as a oriented or directed graph. There is no directions means that is called as a undirected graph. The particular node is connected to the how many branches, that will indicate as a degree of a node. Next, if there is any, if there is no any crossovers, then that is called as a planar graph. If there is a crossovers, then that is called as a non-planar graphs. So we can, I can explain these three terms by taking a circuit which is a graph with another example. So here I can give that is oriented and undirected graph, oriented that is directed and undirected graphs. So you see here two examples are there, about two examples. Is there any directions? No, there is no directions. Just they indicated that first triangle diagram or else first circle diagram. There is no directions from 1 to 2, 2 to 3, 3 to 4 nodes. Okay, but in second diagram also there are 4 nodes, but each and every node branch does not having any directions. How the flow of a particular network is going on, we don't know. But you see in the third diagram. So third diagram, which is the same triangle representation having a 4 nodes, there we are showing a direction which is from 1 to 2. That value of A which is passes from 1 to 2 here. The value of A which is passes from 1 to 2, and next here 2 to 3, and next here which is a 3 to 1, next 1 to 4. Likewise, each and every node, that particular branch direction will indicate it there, and wherever we start, we can take the direction and we are going to end that particular started node. So likewise, if we have like that particular direction, that is called as a oriented graph. Otherwise, that called as an undirected graph. In the slide shown, first two are the undirected graphs, third one is a directed or oriented graph. So we can go for the planar and non-planar graph. I already explained planar. If there is any crossovers between the network, between the branches of a network, then that is called as a non-planar network. Otherwise, there is no crossovers. So there is no crossover means that is a planar network. So in this slide, first network, which is there is no crossovers, which is a very simple manner, which is directly we are connected individually. All the branches are connected individually. So this is called as a planar graph. And this you observe here, this one A to F, or else here node to node for these nodes, A node, C node, A node, C node, and here B node, F node, A node, C node, B node, F node, or crosses each other. So in order to draw B to F, we are crossing the A to C branch. So here we are having a crossover, and here again B to D and A to C. If you want to draw the A to C, we need to cross the B to D branch. So here also another crossover is there. So this network is having a two crossovers. So crossover exists. So this is called as a non-planar graph. Okay. So next, these are the main three terms we are going to use in any graph. That is, first one is a oriented or oriented and undirected graphs. Next one is a degree of a node. Last one is a planar and non-planar graph. So up to now we cleared how to draw a graph of a particular network. Then how to draw a tree. What is meant by tree and what is meant by cotree. So next we'll explain that tree. So here, in order to draw a tree for that particular graph, we should join all the nodes with the minimum number of branches used. Okay. So for example, in a network or in a graph, we are having 6 branches. Okay, 6 branches and 4 nodes. So in order to draw a tree, we should join all 4 nodes. But you have to use the minimum number of branches, not equals to 6. Okay, less than 6 you should use as a branches, and maximum, that is how many nodes are there, you should draw that, you should join all the nodes with the minimum number of branches. If you draw like that, that particular subgraph, we are drawing the graph, by using that particular graph, we are going to draw the another graph. So this is called as a subgraph of this particular graph. So this particular subgraph, if that particular subgraph is connected to all the nodes as well as number of branches or less when compared to the actual graph, then this subgraph is called as a tree. Okay, this subgraph is called as a tree. So remember this 2 points. While drawing a tree, the number of nodes in a particular graph should be equals to the number of nodes in a tree. The number of branches in a tree should be less than the number of branches in a graph. So these 2 points you should remember. So I'll take one network. So this is a network. I already taken the network and I draw the graph for that particular network that is shown in figure A. For example, which is having a nodes. 3 nodes are there, 1, 2 as well as 3. Those 3 nodes are connected with the values, with the branches of 4 branches, A, B, C and D. So here 3 nodes are there, 4 branches are there. So in order to draw the tree, first you should place the nodes 1, 2 as well as 3. Okay. So we should join all the nodes with minimum number of branches. Okay. So here we are going to join 1 and 2 with the branch of B, 1 and 3 with the branch of A. Just we used 2 branches to join the 3 nodes. Okay. Here 3 nodes are joined with minimum number of branches. How many number of branches we used here? Only 2 branches. Actual graph that consists of 4 branches, right? But here in the subgraph, just by 2 branches we joined all the nodes. Whatever 1, 2, 3 nodes are there. So this graph is called as a subgraph. Particularly this is called as a tree. Why? Because we connected all the trees, all the nodes at a time with the minimum number of branches. So this is called as a tree. So how many possible trees we can draw? So possible trees, there are many number of trees we can draw. So here I am not showing. So here we can draw in the another pattern also I will tell. That is 1 and 2. Here in the previous first diagram, 1 and 2 and 1 and 3 are joined with the branches of A and B. Another tree, how we can draw? 1 and 2 with the branch of B, 2 and 3 with the branch of C. That is another tree. or else 1 and 2 with a branch of B, or 2 and 3 with a branch of D we can take. So all nodes are joined in this third example also, or else we can take this this pattern, 1 and 3 joined with A, 3 and 2 joined with D. Okay, so these are the so many five graphs we can get, 5 subgraphs we can get by the particular graph. So these all 5 subgraphs are called as a trees of that particular network. Okay, so here I taken one example with from the textbook. So this is which is a triangular representation. This is the actual graph. We need to draw the subgraph of this network. So how many nodes are there you see here? So nodes are 4, 1, 2, 3 as well as 4. So 4 nodes are joined with the how many branches? 1, 2, 3, 4, 5, 6. So there are 6 branches. So branches are 6 here, nodes are 4. Okay. So we have to draw the tree with the all nodes are joined with a minimum number of branches. So you observe here how many trees we can get. Entire 12 trees we can get with a particular graph. So 12 trees we can get. So first network, just I will explain one tree. Here first one that will be joined by taking 2 and 4, 1 and 4 as well as 4 and 3. So 4 and 3, 1 and 4 and 2 and 4 joined together. So 2 and 4 we are having a branch of, what is that branch? Which is E here, and here 1 and 4 which is a branch of C here, and here 4 and 3 that is a branch of D. So E, C and D, just by taking 3 branches here we join 1, 2, 3, 4 nodes. So likewise you draw for all the subgraphs, all the trees for this particular graph. Okay, so next we'll go for what is meant by twigs and what is meant by links. So here I taken one example. So let us take, this is a graph of a network. So graph of a network which is having same again 4 nodes are there, 1, 2, 3 and 4, and those 4 nodes are connected with the 6 branches here, A, B, C, D, E, F. Okay, these are the 6 branches. So we are going to draw a tree with a minimum number of branches. So first in the second diagram I shown, that is the second exact below of that particular graph. That is let us take, that is a tree of that particular network, which is 1, 2 and joined, 2, 4 are joined, and 2 and 4, 3 are joined there. Okay, so with 1, 2 are joined with the value of A branch, 2 and 4 are joined with the value of C, and next 4 and 3 are joined with the value of E. Okay, so what is that one? That is called as a tree of that particular graph. That is the tree. Whatever the branches we are going to use in a particular tree are called as a twigs. Okay, here this is a branch we used to build a tree. So this branch is called as a twig of that particular tree, and this A, C, E, these 3 branches are called as a twigs. The not used branches in a tree. In this network, what is the not used branches? That are D, F as well as A. A, D, F. These 3 are the not used branches. Those are indicated with a dotted line. Those particular not used branches that will form a network, that will form a graph. That particular graph is called as a cotree. Okay, are you getting? So here the branches are not used in the tree. Those are form another graph that called as a cotree. Whatever the branches used in a cotree are called as a links. Okay, so here this dotted network, this dotted line, dotted network which will form another graph, the branches used in that particular graph cotree are called as a links. The branches which are used in a tree are called as a twigs. Okay, twigs and links. You remember these 2 points. Twigs are nothing but the branches used in a tree. Links are nothing but the branches used in a cotree. Okay, are you clear? So here, fundamental theorem of a network topology. We already seen, that is we draw a network, we draw a graph with a network, we draw a subgraphs by that network or by that graph. by taking a tree or cotree. But how many branches should have in that particular network? How many branches are there? How many nodes are there? How many loops are there? So depending upon what, we can calculate the branches also. Here I shown a network which is having here node 1, which are voltage source as well as a resistor are connected, and here that will form another node which will having 3 branches joined together, 3 resistors, and here these 2 resistors are parallel. Here actually that will shows the 2 dots, but those 2 dots are same common point, so we take it as only one node. Here this node is connected to 1, 2, 3, 4. 4 resistors are joined with the value with the node of 3, let us take. And here 4th node that will formed by 2 resistors and 1 current source. And here all second ends of the voltage source and resistors are common. So common nothing but all are connected to a particular point that will also act like a node. So total how many nodes are there? 1, 2, 3, 4, 5. So total 5 nodes are there. So here they indicated with the value of n is equals to 5. So total how many loops are there? You observe here. This is a first loop and this is a second loop, third loop, fourth loop and fifth loop. Okay. 1, 2, 3, 4 and 5. So 5 loops are there. So 5 loops. So I can indicate that value is L is equals to 5 here. Okay. So then we can calculate the branches. How many branches we can use in a particular network or particular graph by the formula, that is B equals to L plus N minus 1, where B is how many branches you are going to connect, L how many loops that exist, N that is how many nodes there will be, minus 1. So here we already know that how many nodes are there, which is nodes are 5 nodes are there. So 5 nodes are there as well as 5 loops are there. So value will become 5 plus 5 minus 1. So total how many? 9 branches we can connect. So 9 branches you can count also. So here first branch, second branch, third branch, fourth branch, fifth branch, 6, 7, 8 and 9. 6, 7, 8 and 9. So these are the 9 branches we can use in a network. Okay, likewise we can calculate the branches, which is B is equals to L plus N minus 1. Okay, so this is another network I taken. With this network I derived or I draw a graph. All capacitors, inductors, resistor or voltage sources, whatever it may be in a network. If that is a 2-terminal device, then we can replace it with a single line segment by joining the nodes. So here this network which is having 4 nodes, 1, 2, 3 as well as a common node that taken as a 0. Okay. So this first node is connected with the capacitor. So likewise we connected second node, first node and 3 branches are connected. So second node, that is 3 branches are connected. Third node which is connected with the 2 branches and common to all, that we can take it as a 0. So this is a graph theory, basic graph theory. So up to now just we drawn the graphs, different graphs, right? So by that graph, how we are going to interlink with the mathematical expression, how we are going to calculate in a mathematical way by taking the particular graph. By taking here, we are going to write an incidence matrix for that particular graph. So how we are going to write the incidence matrix? So here this matrix consists of only 3 values, 0, 1 as well as minus 1. So 0. Whenever if a particular node is not connected to that particular branch, for example A, B, C, D, E, F, these are the branches, 1, 2, 3, 4 are the nodes. If one node is not connected to the particular branch A, B, C, D, E, F, if 5 branches, if these 5 branches, 7 branches, whatever 6 branches are there, if any branch is not connected to that particular node, that particular value will become 0. Okay, so to write the incidence matrix, that should be a planar network, that should be a planar graph, nothing but that should indicate the directions. If the particular node, that particular branch value is leaving from that node, then we are going to take it as a 1. Okay, so that branch is incident on that particular node and that is leaving from that node. So away from that node, if the direction is away from that node, then that is we are going to take it as a 1. Okay, so if that branch is incident on that particular node and that is towards to the node, so the direction of that particular branch is towards the node, then we are going to take it as a -1. Just that will indicate only 3 values. If that branch is not incident, if the branch is not incident means that branch is not connected to that particular node, we can take the value as 0. If the branch is connected but the direction is away from that node, then we are going to take it as 1. The branch is connected and the direction is towards to the node, then we are going to take it as a -1. 0, 1, -1. Here the matrix size we are going to indicate with the number of nodes and number of branches in that particular graph. So if we have the number of nodes n are there, if we have the number of branches b there, no, so that matrix size that can be indicated with n into b, where n is a number of nodes, b is a number of branches. N we are going to take it as a rows, branches we are going to take it in a columns. So rows that can be indicated by the n, that is nodes, branches that will be indicated in a columns. So we can see one example here. So this is a network, this is a graph for any particular network which is having 4 nodes, 1, 2, 3 and 4, and those are 6 branches are there from A to F, A, B, C, D, E, F. Okay, so there is a matrix which 1, 2, 3, 4, those are the nodes we can indicate in the rows format, and A, B, C, D, E, F, those are indicated in a columns, those are called as a branches. So let us take first row, which is first row which will indicated the node 1 connections. Okay, node 1 connections. So node 1, how node 1 is connected with the branches? Node 1 is connected to branch A. Here node 1 is connected to branch A and nodes branch C as well as branch F. So node 1 is connected to only 3 branches, A, C as well as F. So depending upon the directions, those values are +1 or -1, remaining all values are 0. So you observe. So here one node, first node is connected to the branch A, which is away from the node, So that value we are going to take it as a 1 here. Okay, away from the node, then that value is +1 we should take. Is B branch is connected to node 1? No. So B branch is there, that is not connected to node A. If not connected to, that is not incident on that particular node, then we are going to take that value as 0 here. Okay, are you understanding? So here we are going to take the value as 0. And next finally that C. So C is connected, you observe there, C is connected and that is away from the node. So that value is taking as a 1 there. And D is not connected, so D value is 0 here. E is not connected, that value is also we are going to take it as 0. And here F is connected, that is also away from the node, so that value is also 1. So this is a node 1 values. So you observe node 2. So node 2 is here. Node 2 is connected to A, B as well as D. A branch is towards to the node. A branch is towards to the node, right? So towards means nothing but that should take it as a -1. B is also towards to the node. So that value is also we should take -1. So C is not connected, so that value is 0 here. And D is away from the node, that value is 1. And E, F are not connected, so that values are take it as 0. So likewise we can take the incidence matrix. By taking the incidence matrix, we are going to write KVL, KCL equations in a simple manner to analyze the circuits in a simple way. So this is about the graphical theory, that incidence matrix theory about the network topology. Okay. So in next class we'll continue the next sessions, that is how we are going to write the KCL, KVL expressions by using a incidence matrix, and what is a cut set matrix and what is a tie set. We'll discuss it in the next class. Thank you guys.